Hello, today we are still solving trig equations, section 5.3, but this is day 2 of it. And today we're going to look at some solutions we've already talked about in, just how in general to solve equations. We've also talked about how we solve equations when there's multiple angles, and we're going to look more at that today. But today we're also picking up what happens when you have a factor that does not give you, or you don't have the ability to use a unit circle value. So our calculator is going to come into play. And what makes solving trig equations kind of interesting is that sometimes you may be all exact answers in that you can find all the answers on the unit circle, pi over 3, pi over 6, 3 pi over 4. Or it could be all calculator where you're going to round your answer to 3 decimal places. Or it could be both in the same problem. So one of the things you need to recognize is, one, how do I leave my answers? Is it going to be in a list or is it going to be in an equation? And two, what are my answers going to look like? Are they going to be exact or are they going to be approximations? So we'll take a look at both of those. So if you need to pause the video for a second and run and grab your calculator, be sure and do that. Otherwise, let's dig into these 6 problems that we're going to work our way through. So a few things to remember as we're working through these problems is that solutions will be given as a list of specific angles when the problem says there's a restriction. So we'll talk about what that's going to look like. And when that is the case, then we're just going to say x equals or theta equals or beta equals, whatever the variable happens to be, and we'll list out all the angles that satisfy that equation. Be careful of the plus or minus sign. Dropping that plus or minus sign can result in losing several solutions. So we definitely don't want to do that. Okay, so the first question that we're going to look at, number 1, is 2 sine squared x minus sine x minus 1 equals 0. So the first thing I want you to do is look at what the condition is. And in this case, it's saying find solutions from 0 to 2 pi. So that means my answers for this particular problem are going to be in a list. So I'm going to have x equals, because the x is the variable here, and then I'm going to list out my possible solutions. Okay. So here's the first one. So we're talking about, how I would grade something like this. Remember that there are points available for the work. There are points available for graphing the angles in the right quadrants. And obviously there are points available for all the correct answers. So we want to keep that in mind as we work through it. We're going to work through the problem. We're going to set up our axis with our angles, one for each factor, and then write the answers. Okay? So the first thing I want to do here, 2 sine squared x minus sine x minus 1 equals 0. This should look very quadratic to you, so hopefully you recognize that you're going to be factoring. And so when I factor that out, I get 2 sine x plus 1 and sine x minus 1. So hopefully your factoring skills with your trig functions are getting better. Have no fear. Next period we're going to practice some more. I have a circuit training for you to do that's all about the factoring. So yay. All right. So then we set each factor to 0 because that's that zero product property that we learned back in Algebra 1. And then we're isolating the trig value. So we get down to this statement and this statement. So this is what I mean by I'm looking at the work that got you to the answers that you're going to put on the grids. And then you're going to make a grid or an axis with angles for this one and see what solutions come from that. So I know that sine is negative in quadrant 3 and quadrant 4. And hopefully I know that the angle that has a sine value of negative 1/2 in the third quadrant is 7 pi over 6. But if you forget, you can always label your triangle. So sine is opposite over hypotenuse. And we know that when we're looking at this angle right here, the side opposite is negative 1. And the angle opposite negative 1, that means it's opposite the shortest side in the triangle, which means this has to be the smallest angle in the triangle. And if it's a 30, 60, 90 triangle, then that has to be 30 degrees. And we know that if it's 30 degrees, then that's pi over 6 in terms of radians. So then I would come down here and say, okay, what's the pi over 6 angle in the third quadrant? That's 7 pi over 6. What's the pi over 6 angle in the fourth quadrant, which is 11 pi over 6? Then I move to my second factor. Well, when is the only time on this grid or this axis that sine can be 1? And that's up here on the positive y-axis at pi over 2. So once we have our graphs here, which would get me another point in the work, then I list out my answers. So it's 7 pi over 6, 11 pi over 6, and pi over 2. Sometimes teachers want you to put it in order. I'm okay if you put the factors that go together in the same graph together. Sometimes that's a little bit easier for me to grade, but I can grade it either way. And then we want to make sure that all of these answers definitely fall within our restriction, which is 0 to 2 pi. And so that's how we're going to proceed through these particular problems. And remember, solutions will be an equation if no restriction is given. So if you don't see this 0 to 2 pi here, then you're going to write the equations that represent all possible solutions. That's the coterminal angles to the solution in the first rotation from 0 to 2 pi. And we have already practiced that, so that will be a review as well. Okay, so problem 2 is broken up into part A and B. What I want you to notice is right here, that's cosine 3 theta. So that's a multiple angle. And we're going to solve it both ways. We're going to find all possible solutions, which means this is going to be answering in the form of an equation. And then part B, we're going to do the same problem, but this time we're going to find all solutions from 0 to 2 pi. So B will be a list. And theta is the unknown, so I would say theta equals, and I would list out all the possibilities. So that's what we're going to do on problem 2. Okay, so we said 2A, we would be finding all solutions, so our answer is going to be in the form of an equation. The first part doesn't change. We still need to isolate the trig function. But remember, when I've isolated the trig function, that's cosine of 3 theta equals 1/2. So this does change things a little bit, and we want to think about that as we're working through the problems because we're thinking about this like we did before earlier in the year. If you remember, we said, okay, let's think about that as cosine theta equals 1/2 because we're familiar with that. And then we figured out where that was, and then we can make that adjustment to 3 theta at the end. So that meant we would lay out our triangle based on the fact that we know cosine is positive in the first and the fourth quadrant. And so hopefully we know the angle that has a cosine value of 1/2 in the first quadrant is pi over 3. The angle that has a cosine value of 1/2 in quadrant 4 is 5 pi over 3. If you forgot, then you could lay out your triangle and you can see that the side opposite this angle here is root 3, which is a 60-degree angle, which is pi over 3. So then you could get the pi over 3 angle here and the 5 pi over 3 angle here. I know that I repeat that and I say that a lot. I hope by now you're not having to do that too much. But I want you to have me in your head, so if you're taking an assessment or something and you go, oh no, I can't remember, that hopefully one of the thousands of times I have went through that process with you will go, oh yeah, wait, Miss Adams gave us a strategy. So hopefully that will work. All right, so what we're going to do then is we are going to lay this out so that we have 3 theta equals pi over 3, that's the smallest angle here, with the rotation of 2n pi. So remember, we add 2 pi to get back to here, and then n represents the number of times you're going to rotate. But we're not solving for 3 theta, we're solving for theta, so I need to get rid of that 3, which means to do that I'm either going to divide by 3 or I multiply by 1/3, but it's really the same thing. So if you're going to do that, everything gets divided by 3. Once you have taken care of that division, you have your new equation, theta, not 3 theta, which is now pi over 9 plus 2n pi over 3, and nes, which remember n is the number of rotations included in the set of integers. And so we want to guarantee that we're rotating around these whole number terms in the problem. So that's what your solution is going to look like. So you can see this looks like an equation, not a list. But wait, there's more, because there's another angle right here, which is 5 pi over 3, and so we need to do it all over again. So 3 theta equals 5 pi over 3 plus the rotation 2n pi. I need to get rid of the 3, so I'm going to divide everything by 3 or multiply everything by 1/3. And then I'm going to have this. So I have theta equals 5 pi over 9 plus 2 pi n over 3, and then we add our nes. So this would be one solution, and this would be the second solution. And so what happens then is a rotation of like 7 would go in here, and then we could get 2 times 7 is 14. So I'm adding 14 pi over 3 to pi over 9. and that would give me another angle. So that's what that rotation does for us, is it helps us figure other angles no matter where the equation stops. So this is the first way to do this problem, and it's the way to do it when it's all solutions where you have no restrictions. Now we're going to do the same equation again. 2 cosine 3 theta minus 1 equals 0. And we're finding all solutions, but see how it restricts it here? It says from 0 to 2 pi. So that means initially when I'm working this problem, I'm going from 0, including 0, through theta to 2 pi. The problem is it's not just theta from 0 to 2 pi I'm solving for. Remember, it's 3 theta. So that means we're going to have to adjust where I find my angles. And if you remember way back when you started learning about inequalities, when you had a compound inequality, if you multiplied the middle by something, you had to multiply the other parts of the inequality by something. So I'm going to multiply theta by 3 theta, because after all, that's what's in my equation. And if I multiply this by 3, then I multiply this by 3, I multiply this by 3. And so now I'm looking for angles that go from 0 less than or equal to 3 theta less than 6 pi. And hopefully that should make some sense to you, because we've studied transformations, and we know that when we have a number in here on the cosine, that means it's a horizontal compression by 1/3. So 1/3 of the way from 0 to 2 pi, we've completed one full cycle of cosine. And then from that to the next third would complete a second full rotation of cosine. And finally, from that point to 2 pi would make a third rotation of 2 pi. Well, if I'm going to get 2 answers every time I do a rotation, then if I'm going to go out to 6 pi, I'm going to get 3 rotations or 6 answers. All right, so the first thing that we would do is we're going to solve and draw our diagram. And we don't really have to do it all the way from scratch, because we really did just do it up here. So I know that that's what it's going to look like isolated. I know we did our graph here, so I know that's what my graph's going to look like, because you won't be doing it both ways. You'll be doing it one or the other. So we would have tackled all this. And like I said, we already did it on the last problem, so no sense in rehashing that. Then the difference here is we're not doing an equation. Remember, we said it was going to look like a list. So what am I listing? Well, 3 theta is what I'm finding. And I'm going to list the angle pi over 3 and 5 pi over 3. So if you remember when you're working problems like this, so let's say I want to do a rotation here. So let's say pi over 3, and I want to go all the way around the circle and stop back there again. Then I have to add 2 pi, and when I add two things together, I need a common denominator, so that common denominator is 3. And if I'm going to do that, then I need to multiply the top by 3, so that's 6 pi. So I'm going to add 6 pi to pi over 3, and that's going to get me all the way around the circle, and I'm going to stop there again. So that means I'm going to have 6 pi plus 1, which is 7 pi over 3. So when I go around the circle one whole time and I stop at that place, I get 7 pi over 3. If I begin at 5 pi over 3 and I go around the circle one rotation, well, I already know what the common denominator is, so really I'm just doing this. So then I would say 5 plus 6, which is going to give me 11 pi over 3. And so that would be if I was here and then I went around the circle one time and stopped on the second rotation, I would be at 11 pi over 3. So what we're going to do is we're going to list all of those out until we get to 6 pi. All right, are you with me, I hope? You can always pause the video if you need to. So I have 3 theta because that's what I'm solving right here. And I said the first rotation is in my diagram, so that's pi over 3 and 5 pi over 3, which takes me to 2 pi. So now to go from 2 pi to 4 pi and stop here and here in the next rotation, I would add that 6 pi over 3, and that gets me 11 pi over 3, 7 pi over 3 and 11 pi over 3. So now I'm at 4 pi. Well, where is it I'm needing to go? Out to 6 pi. So I need to go around the circle one more time. If I go around the circle a third time, stopping here and stopping here, then I add 6 pi over 3 to 7 pi over 3. So 7 plus 6 gives me 13 over 3. And then 11 pi over 3 plus that 6 pi over 3, which gives me 17 pi over 3. And so now I'm all the way out to my 6 pi. But remember, it isn't just 3 theta, right? It's theta that I'm solving for. So just like we did up here where we multiplied by 1/3 to get rid of the 3 that's with the theta, I'm going to do the same thing here, and I'm going to multiply all of this. So every single one of these angles are going to get multiplied by 1/3, as well as 3 theta is going to get multiplied by 1/3. And so when we do that, we get pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, 17 pi over 9. You could generate the two equations like you do with all solutions and then plug in rotations, and each rotation would give you one of these answers. But that means you're having to evaluate the equation for every single answer. And as you can see right here, it was super easy to just add that 6 pi over 3 to what we needed to do. And then we easily had our solution. So there are other methods, but I prefer this one because I think it's easiest and makes a lot of sense. So if I were going to assess something like this, you would definitely get a point for showing me that you're changing how far out you're going to rotate through. You would get a point for your work that led up to the solution. You would get a point for your graph with the angles. You would get a point for showing me what it is you were finding in your rotations. Now you don't have to label it like this down here, just list them. And then finally for the solution itself. So that kind of gives you an idea. This problem might be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points because there's a lot of answers on that one. All right. Problem 3, we're looking through right here. We're finding solutions from 0 to pi. So this means I'm going to have a list, and the unknown is x, so my final answer will be x equals. Okay, so this problem on 3, it's find solutions from 0 to pi, and we have a multiple angle there. So we have talked about how that changes what we're doing a little bit. And then we are giving our answer as a list. Okay. So we would start by showing our adjustment in what we're talking about, because this is x over 2 is the same thing as 1/2 x. So if the original one is going from 0 to pi, then in the adjusted one we go from 0 to pi over 2. So remember to include that in your work when it's a multiple angle. And then we go about getting the tangent function by itself. So I moved the 3 to the other side. It became -3. And then I divided by 3 to get rid of that 3 right there. So I get tan of x over 2 equals -1, or tangent of 1/2 x equals -1. So then tangent can be negative in these two quadrants. And I know the only time tangent can be 1 or -1 is if sine and cosine are the same thing, which leads me to know that it's a pi over 4 angle. And the pi over 4 angle in the second quadrant is 3 pi over 4. And the pi over 4 angle in the fourth quadrant is 7 pi over 4. Okay, so hopefully you kind of see there's an issue there to begin with, right? Because if I'm looking at the original one from 0 to pi, well, obviously 7 pi over 4 can't be an answer. If I'm looking at the adjusted, then I've got even bigger problems because 0 to pi over 2 would be here. This 3 pi over 4 is in the second quadrant, which is past pi over 2. And then 7 pi over 4 is way out of the area. So this actually ends up being a kind of an interesting problem. So even if you didn't recognize that, when you said, oh wait, that's out of the range, okay, and you didn't catch that this was, then you could still set up your equation, which would be 1/2 x, because that's what's right here, equals to 3 pi over 4, because that's the angle that's right there, which is from 0 to pi. And then you would adjust, and you get x equals 3 pi over 2. Well, 3 pi over 2 is down here, which makes it outside. So when neither of the possible solutions will work, remember we're going to use the empty set and then we're going to explain. So something like none of the possible solutions fall in the restriction of 0 to pi, or the adjusted restriction of 0 to pi over 2, you could have said that too. So the problem has no solutions. If you're going to include the empty set in your work, then you have to be able to tell me why. It doesn't have to be huge and elaborate, but there has to be some reason. Because just putting the empty set because you don't want to work the problem or don't know how to work the problem doesn't work for me or you because you want the points. All right, so that's problem 3. Okay, so problem 4, so we're looking here and we find that it says find solutions from 0 to 2 pi, so that means that my answer is going to be a list, and the variable is x, so I would say x equals when I'm giving my solutions. So problem 4, cosine x plus 1 equals sine x. So I have to think about my strategies. I want to isolate the trig function to be able to solve or to be able to factor. I want to set it to 0. And the problem is I can't really do either because I don't have identities that are going to help me get anywhere. I can't isolate one trig function without the other trig function still having something with it. So my only strategy for solving this is squaring both sides. And the problem, remember, with squaring both sides is that's when I could possibly produce an extraneous solution, which means a solution you get when you do all the work right, but then when you plug it back in, it doesn't work. And so this is a case where I would have to check my solutions to see if any of the solutions that I created by squaring both sides don't work in the problem. Okay, so I square both sides, and then let's see, get this out of here the way so you can see. So when I square both sides, I get sine squared. Please be very careful. That power of 2 goes between sine and x. I'm seeing a lot of students are putting it on 2, which actually means sine x squared, not that sine is squared. So be careful of your placement there. And don't forget you have to FOIL over here. If you don't FOIL over here, you're going to miss your middle term. All right, well, I can tell right now something is up because they're all in different trig functions and I can't factor with them in different trig functions. So I'm going to use my identity and replace sine squared x with 1 minus cosine squared x. So now I have everything all in the same trig function, so I can start moving it around and making it set equal to 0. So cosine is going to come over here with this, and it gives me 2 cosine squared. 1 is going to come over here with the 1, and that's going to make it go away because 1 minus 1 would be 0, and I still have the 2 cosine x in my problem set equal to 0. So that is me squaring. Okay? As we go through this, taking out the GCF is going to look something like this. And so now I have 2 factors, so I can set this factor equal to 0 and create a graph showing my angles, and I'm going to set this equal to 0 and create a graph showing my angles. So when I do that and isolate my trig function, I get to here. So I have 2 cosine x equals 0, cosine x equals 0. Here I have cosine x plus 1 equals 0, cosine x equals negative 1. So then when you set up your graphs for these two, we have the only place where cosine can be 0 is at pi over 2 and 3 pi over 2. The only place where cosine can be negative 1 is at pi. So the possible solutions are these 3 angles. However, because I squared both sides, that doesn't necessarily mean they all are actually the correct angle. So what I need to do is I need to take this angle and I need to go back up here to the original problem and substitute in. So I would find cosine of pi over 2 plus 1, and that should equal sine of pi over 2. And then we would find cosine of 3 pi over 2 plus 1, and that should equal sine of 3 pi over 2. And then I would find cosine of pi plus 1, and that should equal sine of pi. So I go through all of those possibilities. And so when I'm working this out and checking all these possibilities, I find that cosine of pi over 2 is 0, plus 1 is 1, sine of pi over 2 is 1, so they are equal. So pi over 2 is a solution. Not just a possible, but an actual solution. And then when I do 3 pi over 2, cosine of 3 pi over 2 is 0, plus 1 is 1, sine of 3 pi over 2 is negative 1. So, problem there, right? 1 does not equal negative 1. Therefore, 3 pi over 2 cannot be a solution. And then I test pi. So cosine of pi is negative 1, plus 1 is 0, sine of pi is 0. These are equal, so I know this is a solution. So then for my final answer would actually be x equals pi over 2 and pi. Now you don't have to list the possible solutions. You can see what the possible solutions are from your graphs. I just went ahead and did that for notes purposes so you would could follow through my process as I was working through the problem. So my final answer and my final solutions are x equals, because it is a solution, pi over 2 and pi. For problems 5 and 6, you do need a calculator, so pause the video if you don't have your calculator handy and run and grab that. When I'm looking at 5, the problem here is 2 sine x plus x equals 0, and notice it says find solutions from 0 to 2 pi, so I know that means my answer is going to be a list The unknown is x, so I write my final answer as x equal and list out the possibilities. All right, so that's what we're going to do then. We're going to list the possibilities from 0 to 2 pi. Unfortunately, this is very similar to the last one we did. So we have 2 sine of x and we have cosine of x. So there's no way to just isolate one function, and we don't have any Pythagorean identities or that kind of stuff that's going to help us. So we are going to need that calculator. And let's go through the process. So I moved the cosine over. I squared both sides. And so again, the square goes between cosine and x, and the square goes between sine and x. So make sure you're taking care of that properly. I move it all to the same side. Then I used an identity to get everything into the same trig function, being careful to note that when I subtract, I'm subtracting this quantity. So it's -1, and that's minus a negative sine squared x. So that actually means I have this. So now I can collect my like terms. I have 4 sine squareds here. I have 1 sine squared there, so a total of 5 sine squareds and the -1. And so then I'm going to isolate sine squared. So I'm moving the 1 over and dividing by 5. Now notice I have sine squared theta, not sine theta. How do I get rid of sine squared theta? Well, I take the square root. So when I take the square root, remember that right here you're going to put plus or minus. And then the square root of 1 is 1. The square root of 5 is square root of 5. And so we've isolated. We've got to this point. We have a plus minus. What does that plus minus mean in terms of solutions? Well, there are 2 places on our grid where sign can be positive, and 2 places on our grid where sign can be negative. So I'm looking with the plus or minus there for 4 angles in that rotation from 0 to 2 pi. All right, so I'm going to lay it out. And when I draw this, I would probably just have these 3 bars right here, because then we're going to go to the calculator and talk about that. So the first thing I want you to know is we're going to use the functionality of the calculator, and we're going to use the sine to the -1, which in the past we've definitely talked about that being an inverse, but we're not doing an inverse problem here. We're just using the fact that the calculator will calculate an angle for us if we happen to use this. So no restrictions, none of that stuff. And then the angle we find in the first quadrant will be our reference angle. And we spend a lot of time remembering how to do reference angles, right? So we're going to calculate this reference angle, and that's your first quadrant. And then to get the angle in the second quadrant, we take pi minus the angle. Well, we will already have that angle in our calculator, so we just have to do that. You can store it, or you can just go up and find the angle. And then in the third quadrant, we take pi plus that angle. And then in the fourth quadrant, we take 2 pi minus this angle. So if you need a real quick refresher on reference angles, don't forget the information on reference angles is on the back of your purple trig identity sheet. So now let's go and actually do that so you can kind of see how it's going to work out. Let me get my calculator where there's not a glare. All right, so I'm going to do this right here. So I'm going to use the inverse second sign, and I'm going to put in the fraction. So I do alpha fraction template. You might as well make it look exactly like your paper so you don't have any entry errors on your parts. So see, it looks just like what I'm calculating there. So when I hit enter here, that's going to give me this angle right there. And that's our reference angle, because every angle in the first quadrant technically is a reference angle. It's all less than 90 degrees and positive. So then to get in the third quadrant, I'm going to take second pi, and I'm going to subtract the reference angle by just going up and grabbing it. And then I now have this angle right here. So to get this angle, I'm going to take pi, and I'm going to add the reference angle to it. So I go up and grab the angle again here. And that gives me my angle here. And then I'm going to go into the fourth quadrant and do 2 pi minus the reference angle. And that gives me this one. So I have 4 possibilities. Now remember, we did square both sides, so maybe not all 4 of these possibilities will work out. So when we get our possible solutions, those were the 4 that we found down here in the graph, then we've got to take and plug them back into that original equation right here and check. So when I plugged in, and I'm not using the rounded answer here, I literally typed in 2 sine, grabbed my number, plus cosine, grabbed my number, and checked to see if it was 0. And then 2 sine, grabbed my number, plus cosine, grabbed my number to see if it's 0. Then 2 sine, grab my number, plus cosine, grab my number, see if it's 0. 2 plus sine plus cosine, grab my number, and it's 0. And so when I calculated these on my calculator, this one was not 0, this one was not 0, so that left me with these two as my actual solutions out of my 4 possible, and that's what I write down as my final solutions. So hopefully that kind of helps in the checking. But use the calculator. That's the whole point of that calculator question. Last problem, number 6. So we're using this trig function and find the solutions from 0 to 2 pi. So that means our answer is going to be a list. The variable in the problem is theta, so I'll write my final answer as theta equals. So we're going secant squared theta plus 2 tan theta equals 4. So I moved everything to the same side, and then I replaced with the Pythagorean identity secant squared theta with 1 plus tan squared theta. I did that because remember we can't factor if it's not all in the same trig function. So when I do this, now I have it looking more like a quadratic because we have a power of 2, a power of 1, and some constant numbers. So when I clean that up, I get tan squared theta plus 2 tan theta minus 3. So we're looking at the trinomial here that we're trying to factor, and that's going to break down to tan theta minus 1 times tan theta plus 3. I don't care what factoring method you use, but we want to definitely factor it. Make sure that you write it down in terms of tangent. Don't accidentally slide in x squared or x minus 1 and x plus 3, right? You can use some of those strategies to help you figure out the factoring if you need to, but we definitely want to factor in terms of the problem. So then we set each tangent function, isolate it, set it to 0, isolate it, and we get this. And then each function is going to produce a graph. So I know that tangent is 1 when sine and cosine are the same, so that has to be pi over 4 and 5 pi over 4 because tangent is positive in quadrant 1 and quadrant 3. Over here, the tangent theta equals -3 is not a trig function, so I'm going to have to use my calculator on this. So I'm going to get exact answers here. I'm going to get calculator answers here. So to get my actual values on the calculator then, I'm going to take my handy dandy calculator and I am going to find the arc. So I'm going to use tan to the -1 of 3. And remember, we're going to use the positive value, because if we use the positive value, that's always going to give us a reference angle in quadrant 1. Now I realize I don't need the angle in quadrant 1 because tangent is negative in 2 and 4. But if I use the positive arc, I'm going to get it in here, and I now know what my reference angle is, and it's super easy then to just go pi minus and 2 pi minus. If I use the negative version, then I'm going to have to locate where that angle is, figure out what my reference angle is, and work my way backwards. So that's a couple of extra steps that I'm all for not needing to do. All right, so I'm going to do second tangent. I'm going to use the positive value of 3. And that's going to give me my reference angle. So I put a dotted line here because this isn't actually a solution, but this is what the reference angle is, and so that's what I'm going to use. So I know I need the angle in the second quadrant, so I'm going to do second pi. I'm going to subtract. I'm going to go up and grab that reference angle, and that gives me this angle over here, which is 1.893. Then to get this one, I'm going to do 2 pi. And I'm going to subtract and go up and grab my reference angle again. And so my answer here is going to be 5.034. So notice this is not a solution because this is the reference angle, and it wasn't asking for a reference angle. It was asking for the angles that are in quadrant 2 and quadrant 4, again, because that's where tangent is negative. So I put on here possible solution, but really I would look at my solutions themselves, and I would use the 2 from this factor, so I get my pi over 4 and 5 pi over 3, which are exact, and we always use exact answers when they can be given exact. So if you start giving me decimals for these, I will be counting them incorrect. Exact answers are must, and then the approximations come from this factor, and they are the one in the second quadrant and the one in the fourth quadrant. So I have these two values. So be real careful and don't include the reference angle here, and that's why I put the dotted line. That's one of the ways for my own personal record keeping, keeps me from accidentally including angles that really aren't part of my solution. And so that gives us the last one. So you can see in this problem, this is an example of a solving equation where you had some exact, you had some approximation, all within the same question. All right, hope that helps work and explain that. Work on your worksheet problems. Make sure you're ready to tackle this and be prepared with questions when you come to class, so I'll know if you're having trouble using your calculator or having trouble with the process, and we can definitely take a look at that and make sure everybody's in a good place. Thanks so much, guys. See you next time.